to the GCSE Math series. Today we're going to be taking a look at some exam style questions for spheres and cones. So let's get straight into it. So this question tells us that we have a cone and the height of this cone is 20 centimeters, but the base of the cone has a diameter of 16, meaning the radius is equal to 8 centimeters. Okay, work out the volume of the cone, and the volume of the cone, they provide a formula for us here, which is something they will tend to do in the exam. Volume equals to a third pi times by r squared times by h. So putting this into our calculator, we get a third times by pi times by 8 squared times by 20, and we get 1340 centimeters cubed. Okay, looking at the next question, we have a diagram showing a solid shape. The shape is a cone on top of a hemisphere. The height of the cone is 12 centimeters. The base of the cone has a diameter of 10, meaning radius is equal to 5 centimeters. The diameter of the hemisphere is 10 centimeters. Again, the radius is going to be 5. Work out the total volume of the solid shape. So, first we're going to work out the volume of the cone, which is going to be 1/3 times by pi times by 5 squared times by 12, which is going to be 100 pi. If we put that into our calculator, then we work out the volume of our hemisphere, which is going to be 2/3 times by pi times by 5 squared, which is going to be 250 over 3 pi. So, adding these together, oh, I forgot to mention, why this is 2/3 here is because we are timesing we're dividing, so the volume of a sphere they've given us here is for the whole sphere, and our hemisphere is simply a half of that sphere. So a half times by our 4/3 is going to give us 4/6, which is equal to our 2/3. Hence the formula is 2/3 times by pi times by 5 squared. Okay, adding these together, we get the total area to be 550 over 3 pi, because we're told to leave our answer in terms of pi, and obviously the units are centimeters cubed because we're dealing with volume. Moving on, we have that diagram shows a sphere and a cube. The cube has length 7 centimeters. The sphere and the cube have the same volume. Work out the radius of the sphere. So we can first work out the volume of the cube, which is going to be 7 times by 7 times by 7, which gives us 343 centimeters cubed. Now we have an expression for our volume for our sphere, so we know that at some point, for some value for a radius, we'll get this, because it tells us that the volumes are equal. So we know for some value of r, this expression for the volume will give us an answer of 343. So we can do 4/3 pi times by r cubed is equal to 343. Then r cubed is equal to 343 divided by 4/3, which is going to give us r cubed is equal to 81.885. Then we notice that our r, what we need to find out, is being cubed. So to reverse this, we cubed root both sides. So our r is equal to the cubed root of 81.885. And this is going to give us an answer of r is equal to 4.34 centimeters. So that is our answer here. Moving on to the final question today. It tells us that a rectangular container is 12 centimeters long, 11 centimeters wide, and 10 centimeters high. The container is filled to 8 centimeters. That is our 8 centimeters. A metal sphere of radius 3.5 centimeters is now placed in the water. It sinks to the bottom. Calculate the rise in the water level. So the way we do this is, first we need to work out our volume of the sphere. And when we put that into the volume of our water, so the volume amount of water, we need to add them together to see how much it increases by. So firstly, working out the volume of sphere, we have 4/3 times by pi times by 3.5 cubed, which gives us, from our equation here, we get 343 over 6 pi centimeters cubed. Okay, now looking at our volume of water, we have 12 times by 11 times by 8. That is our formula for volume of a cuboid. So this gives us 1056 centimeters cubed. Now, if we were to add the volume of the water to the volume of the sphere, which is going to be the total volume after they get brought together, we get the total volume equal to 1235.59 centimeters cubed. Now, what we need to work out is how much the water has risen once we put our sphere into there. So now we know our new volume. We know that our formula is height times width times by length is our volume formula for a cuboid. So we know the width is the width is 12, the length is 11, and we now need to work out our h, which is going to be equal to 1235.59, because this is our expression for our volume, and we know at some point the volume is going to be equal to this much. Now we need to work out at what height does this work out to be. So our h, putting this on our calculator, is going to be 1235.59 divided by 12 times by 11 is going to give us a height of 9.36, and this is our new height where the water rises to after the sphere has been put in. So to work out the rise in the water level, we need to use the original level of the water, which was 8, so 8, and minus it from our new to work out that the rise in water level is 1.36 centimeters. Okay, that's going to conclude today's exam style series on spheres and cones. Hope you guys enjoyed the video. As always, shout out to Maths Genie for providing the exam style questions. Please make sure to check them out, and I'll catch you guys in the next video.